welcome to my YouTube channel. Today I will start the power set. So what is a power set? So if we have a given set, then the power set of this set is the set. The power set of this set is the set of all possible subsets of this set. So we already know when we find the subset of this set, then we have two identity here. The first one is empty set is a subset of this set, and the set itself is a subset of itself. The S is a subset of S, and empty set is a subset of S. Then when we find the power set of this set, then empty set becomes an element of our power set, and S itself is an element of our power set. Let's look at counterexample here. If we have a set S has element 1 and 2. So if we want to find the power set of set S, then we should find the subset of S first. So what's the subset of S? According to our identity here, we have empty set is a subset of S, and S itself is a subset of S. Another two possibilities is the set has element 1 and the set has element 2, because in this set we have element 1, and you can also find 1 in our set S. And in this case, we have element of 2 in this set, and also you can find the 2 in our set S. So we have 4 possibilities, 4 subsets of set S. Then what's the power set of S? The power set of S is all possible of subsets of S. The empty set becomes the element of our power set, and S also an element of our power set. And the set has element 1 and the set has element 2 are also elements of our power set. Let's continue to talk about set corporations and Venn diagrams. Let's consider if we have two given sets A and B, which are subsets of a universal set U. What's that mean? Which means if we can find an element X in our universal set, then this element is also an element of A, because A is a subset of our universal set. For same reason, X is also an element of B, because B is also a subset of our universal set. The fourth rule is union of A and B, which means we can collections all elements of A and all elements of B together into our new set. The new set A union B, which indicates if we have an element X in our universal set, then this element is also an element of A, or is also an element of B. It can be illustrated by Venn diagrams. In this case, we can shadow the region to express which part we need to considerations. So in this case, we can shadow the region A and B together, and the whole region indicates A union B. Let's look at counterexample here. If we have a set A has elements 1, 2, 3, and the set B has elements 2, 4, 5, then A union B means we have two collections that all elements of A and all elements of B together, which it becomes 1, 2, 3, 4, 5. The second corporation is intersection of A and B, which means A and B has the same elements, or you can think it as elements are not only in A but also in B. So in mathematics definitions, A intersection B, which means we can find an element in our universal set, and this element is not only in A but also in B. And it can also be illustrated by our Venn diagrams. You can see this graph, and this part is the overlap part of A and B. We can shadow this region to indicate the intersection of A. Let's look at counter example here. If we have a set A has element 1, 2, 3, and the set B has the element 2 and 3, then the overlap part of A and B is 2 and 3. The third cooperation here is difference of two sets, which means elements in one set but it's not in another set. For example, if we want to find B minus A, then in mathematics it means we can find an element in our universal set which is an element of B, but it's not an element of A. Conversely, if we want to find A minus B, then we can find an element which is an element of A, but it's not an element of B. It can also be indicated by Venn diagrams. So let's consider B minus A. B minus A means we can find an element in our set B. Like this, we shadow these regions indicates the all elements of B. And but it's not an element of A, which means we have to take out the part of A. We have to take out the overlap part, so it becomes only this part. So we shadow this one indicated B minus A. And conversely, A minus B. We shadow this part to indicate A minus B. Let's look at counter example here. If we have a set A which has element 1, 2, 3, and have set B here which has element 2, 3, then which element is in A but not in B? Then just 1. So A minus B is only 1. So what's a B minus A? Which elements are in set B but not in set A? So it's an empty set. The final cooperation here is complement of a set. The complement of a set, which means we have an element in our universal set but not in our given set. So in this case, the complement of A, which means we have an element X in our universal set, but X is not an element of A. It can also illustrate it by Venn diagrams as well. So in this case, it's quite simple. We just shadow all regions of universal set except shadow the region of A. Let's look at counter example here. If we have a universal set which has elements 1, 2, 3, 4, 5, and the set A has the elements 2 and 5, then what's the complement of A? We consider all elements of universal set except 2 and 5. So it becomes 1, 2, 1, 3, 4. Thanks for watching my YouTube video. At my next video, I'm going to plan to provide some specific questions to show how do we use a Venn diagram and set cooperation to solve the specific questions. And if you have any other questions or any other topic you want to listen or you want to give me some advice, and you can leave your comments below. Thanks for watching again.